Materials to be used. Fill the graduated cylinder with water up to 20 ml.
When the rain stops, you shine on me.
Then drop the marble into the water and use a timer to record the time it takes from the marble to reach the bottom. Repeat step 2 two more times to make 3 trials. Record the marble's travel time in each trial. Right after, remove the marble and the water from the cylinder and dry them both. Repeat steps 1 to 4 and use pancake syrup or any syrup instead of water.
I just want to be where you are. It's such a strange thing.
Once done, wash and dry the cylinder and the marble.
But it always brings me back to where you are.
Right after, repeat steps 1 to 4 and this time, we're going to use cooking oil. Add 20 ml of cooking oil into the cylinder and let's proceed with our trial 1. Don't forget to take track of the time that the marble once reaches below. Here are the results of the calculated average time it took the marble in moving from the top to the bottom of the liquids. And now let us proceed with the part 2 of the laboratory activity wherein we have to complete the table in order to determine and calculate the viscosity of each liquid using the equation, wherein viscosity 1 and viscosity 2 are the viscosities of liquid 1 and liquid 2 respectively, and D1 and D2 are the densities of liquid 1 and liquid 2 in grams per cc. So T1 and T2 are the time used by the marble took to move from the top to the bottom of the liquids. The formula I use in order to look for the viscosity is 2 times the quantity of the density of our marble subtracted by the density of our liquid times the acceleration due to gravity all over 9 times our velocity. So let's start with our liquid 1, which is our water. Then we have to substitute our given values to our formula, wherein 2 times 2.7 grams per cm cube, which is the density of our marble, subtracted by 1 gram per cm cube is the density of our liquid, which is the water, times our acceleration due to gravity, which is 9.8 meters per second squared, all over 9 multiplied by our velocity. So in order to look for the velocity, we only have to divide by distance traveled over time, which for our case in the water, it's 0.25 meters over 0.23 per second. So our answer here would be 1.09 meters per second. And now, we have to do the same thing with the other liquids in order to calculate for our viscosity. So, for our viscosity of our cooking oil, we do have 4.96 Pascal seconds or 496 millipascal per second. And for our syrup, we have 439 millipascal per second or 4.39 pascal per second. And so you can see this is the summary of the table with our calculated viscosity. And now let us answer some questions. So the first question is that which liquid did the marble take the longest time to reach the bottom? And the answer for this is the syrup, since it has an average time of 0.38 seconds. Let us proceed with question 2. How would you rank the liquids in the order of decreasing viscosity? So first, we will have the cooking oil since it has a 496 millipascal per second as its viscosity. Then next would be the syrup since it has 439 millipascal per second. And lastly, we will have the water which it has 340 millipascal per second as their viscosity. And to answer the last question, what explanation can you give for the observed viscosities? As we all know, viscosity is a liquid's resistant to flowing. So, what we have observed is that the more viscous a liquid is, the longer it will take for an object to move through the liquid.
간지러 넓은 회색 지대가 변해 여기 수억 가지 표정의 그레이 비가 오면 내 세상 이 도시 위로 춤춘다 맑은 날엔 안개 오는 날엔 함께 여기 모든 먼지들